Hello everyone, hope you're having a great day and I welcome you all to this day 6 of AWS series. Today's session is all about Elastic Load Balancer in AWS. So let's check the agenda for this session. In this session, you're going to learn about what is load balancing and how load balancing works. That's all for the agenda. So without any further ado, let's begin. Before we begin, subscribe to Intellipaat and don't forget to press the bell icon to get more updates.
Let's discuss the load balancer. Okay, so what is that? Imagine that you have a web-based architecture and you don't want to depend on one instance, right? You will be depending upon multiple instances in that case. So for example, you have 10 instances, 10 virtual machines at the backend with same set of services and applications running upon them. Now, this begs this question that, okay, you have 10 instances clustered together in an architecture with same set of services and applications running upon them to give you durability, redundancy, backup, and so on. How exactly the traffic would be diverted and managed towards them? There should be someone, for example, you are working in a team, there's a manager on your top. What's the purpose of the manager? Now, he ensures that every person in his team, he allocates some work to every person in his team, say, okay, do that. You need to do this thing by end of the day. So he manages the team. He ensures that the workload is distributed through the entire team members and every person in his team does his job. Similarly, load balancer is a manager on the top of instances. He says, okay, I'm your boss. I'll get the traffic from the user and distribute that traffic, the load, balance that load across all the instances at the backend. You got the point? So he's a manager. He takes the request from the users and puts those requests across all the instances. So it balances the load. So for example, there are 10 instances. It will, and 100% of the traffic distributed across 10 instances. So each instance will get 10% of the traffic. So a load balancer is a service that uniformly distributes the traffic and workloads across multiple servers or a cluster of servers. Load balancing increases the availability and fault tolerance of an application. So the purpose of the load balancer is it uniformly distributes the traffic. Uniformly means that every instance gets the equal amount of traffic and workloads across multiple servers or clusters or services. So anything which needs to be processed or any traffic that needs to be diverted, it goes uniformly, distributed uniformly across the set of instances. Now, how this is useful? For example, I have 10 instances. If 5 of them, they go down, I can divert the traffic and manage them across across the other 5 instances. So it increases the availability and fault tolerance of an application. So it is a single point of contact. So it is the traffic manager, the traffic police. It ensures that the roads are not congested. The network traffic is diverted smoothly, uniformly across all the instances at the backend. Okay. Now, the next thing that you need to discuss is that what are the different advantages of it? It's a load balancing service for AWS deployments. It scales itself as necessary to handle the load. Now it can take care of any amount of load. There's no limit. For example, if you want to scale up further, you can go with network load balancer, which can take care of 1 million of requests per second. So it can scale itself automatically. You don't have to tweak to scale its performance, efficiency. Traffic that comes in through the load balancer, it's distributed equally across multiple availability zones. So it ensures that the traffic is diverted, it's routed across different availability zones uniformly and efficiently. It's a single point of contact for clients. So clients will say, we are sending the traffic to you. You take care of the backend process. So the load balancer will balance the traffic automatically behind the scenes for the front-end users. Okay. Now, there are 3 types of load balancers. Actually, there are 4. One is the new one, the gateway load balancer. It's used for virtual appliances. The first one is the classic load balancer. Now, it resembles the traditional load balancing, but virtual devices replace the physical hardware. Now, this is kind of obsolete. It's not that much used nowadays. It is the very first load balancer that was introduced, classic load balancer, even though it's very advanced in nature in terms of functionality and very efficient. But now Amazon Web Services is saying that, okay, you just stay away of it from that. So they don't advocate that you just go with classic load balancer. Instead, they will say, go with the application or go with network, right? So classic load balancer is kind of, you can see that it's kind of obsolete. It's still there for you to use, but if you want to use it, you're most welcome. Network load balancer. Okay. Now, this is managing sudden and violent site traffic. Now, what do you mean by that? For example, you're running an e-commerce platform upon Amazon's web services infrastructure, maybe Flipkart, let's imagine. And there's a big Diwali sale, big Christmas sale, New Year's sale, Black Friday sale. And you are pretty much sure that there will be a very high peak in traffic during the normal business hours. And for example, you have a big discount going on during Diwali or Christmas. So you expect that, okay, millions and millions of people will visit your website and they will placing orders. So to handle that kind of traffic, you go with network load balancer. It's a kind of Ferrari of the load balancer. It can take care of millions of requests per second, right? Very certain and violent site traffic. And no other load balancer has a capability to replace network in terms of handling so many requests per second. Now, you also go with the application load balancer. Now, this is kind of, you can say that it's used in majority of the cases. It is used for containers, Docker containers, Lambda functions. It also supports something called content-based routing. Okay, so based on the content of the request, it can route the traffic. For example, you want to get the images. It will say, okay, I route a request to those instances. You want to fetch some spreadsheets. Okay, I'll divert your request to those instances, to a group of instances. So it supports content-based routing. It's used for microservices, containers. So it is also, basically it works at layer 7 for HTTP and HTTPS traffic. Okay, and network load balancer can take care of TLS, HTTP traffic, even the UDP traffic, which stands for user datagram protocol. It's used for voice-based applications. Okay. Now, this is the diagram that shows you that how the classic load balancer can function for you. And the same goes with the application. You can see that the traffic is hitting the load balancer. This spherical object you can see is the load balancer. This is the icon of it. It gets the traffic. It distributes the traffic equally across all the instances, across all the availability zones. Okay. Now, this one important thing that you also need to understand, the function of the load balancer is that it ensures that only the healthy instances will receive the traffic. Because if any instance is down, it's frozen. And let's imagine that it is shut down. Okay. So it automatically detects that there's something wrong with the instance, and it will ensure that the user's request is not being sent to that unavailable or unhealthy instance. So it ensures that only the healthy virtual machine is capable to receive traffic. If it's unhealthy, it will stop sending the traffic to it until it comes back up. Okay. Now, network load balancer works as the same as classic, but much more advanced. It works at the 4th layer. I think it's a network layer of the OSI model. OSI is the 7-layer model for the network. It can take care of millions of requests per second with very low latency. Also, it is used for you can also assign an elastic IP to it. Elastic IP is a static IP. It's a static public IP, which means that if you stop and start the instance, it's not being detached from the instance itself. Also, you can switch back and forth between different instances. Now, application load balancer, it works at the 7th layer, the topmost layer, the application layer. Now, it can divert the traffic based on the content of the request for microservices, for Lambda functions, and even for the containers. Okay. Now, this is the one that you'll be using the most in your production environment, because network load balancer is used in very rare scenarios, but where you have a sudden and violent burst of traffic. But in most of the cases, you'll be using the application. Okay. I'll discuss 2 things with you, and then I'll just move forward to the deployment part. So what is health check? See, for example, there's a manager working on the top of you, or you're a manager. Now, you ensure that if a person is sick, you grant him leave so that it doesn't come to the office, because if he comes to the office, he's of no use. If a person is down with fever or he's not healthy enough to do his day-to-day job, you will grant him leave. Okay, you just take your medicine, take rest, come back tomorrow, or maybe once you recover. What's the purpose behind that? Because the unhealthy person will not be able to perform his job. Now, the person will resume once he comes back, once he recovers. Similarly, low pass is employed to ensure that only the healthy resource can get the traffic. Now, how it performs? Let's imagine this circle denotes ELB. It's a load balancer. And this is my EC2 instance. Now over here, this load balancer will, so the thing is that there are two types of traffic you have to understand. One is the data traffic, one is the actual traffic. For example, this is you. You want to access some website. You will type in xyz.com. Okay. And load balancer will take your request. It will say, okay, sir, I take your request. I'm just taking one instance, right? I'm sure that there will be multiple instances, but I'm just giving one example. It will send that user's request to that instance. Okay. Okay, let's take two instances. So load balancer has two instances. The load balancer shows that each instance will get the equal amount of traffic. So these are my EC2 instances. Now, the users comes in and says that, okay, just forward my request to one of the instances, and the load balancer will randomly pick one of the instances and forward the request to it to be processed. Now, apart from that, it also performs, it generates it. So one traffic is the user's traffic. So user's traffic is nothing but it's a user request being sent to one of the instances for processing. Now, the instance will send the traffic back to the user. So instance will say, okay, user, this is your request. I'm sending you back the web page. Now, one thing, the load balancer will only treat the incoming request. It's not for outgoing. User will send the traffic to the load balancer. Load balancer will forward the request to one of the instances. And instance will serve the user directly. It will send the response back to the user directly with the web page. It's only for the incoming traffic only, not outgoing. Outgoing traffic will go back to the user, from instance to the user. It only establishes the connection incoming, but the outgoing request, the response will be served from the instance back to the user directly. Okay. Now, apart from that, the instance also generates its own traffic. The traffic is health check traffic. Simultaneously, load balancer will say, okay, I'll send you a health check request. This is health check. Now this sends the health check to the home page of the application upon instance. For example, it is a / index.html. This is the default page of my website running upon the instance. Now it will periodically send the health check by default every 30 seconds. So this health check is performed every 30 seconds towards every instance automatically. You can manipulate it, you can make it fast, or you can increase up to, I think, 5 minutes. So it will, by default, periodically, it will perform the health check every 30 seconds. Now, if the instance is healthy, right? If the instance is healthy, it will respond back to the instance saying, okay, instance, I'm healthy, using 200 OK as an acknowledgement message. So if the instance is healthy, it's responding. The application and services running upon that instance is perfectly okay. In that case, it will say, okay, instance, I'm healthy. It will send 200 OK message back to the instance, back to the load balancer, and load balancer will say, okay, instance, you are healthy because you are responding to me. Okay. For example, I pick up a phone and say hello. If the other person says hello, this means that I'm audible to him, right? Similarly, if the load balancer sends the health check message to the instance and instance responds with 200 OK as an acknowledgement, so load balancer will say, okay, you are healthy. you're healthy, I will keep on sending the traffic to you. Now, the question, this begs this question, what if this goes down? Now, if this goes down, load balancer ensures that this instance does not receive traffic until it comes back up. And in the meantime, it will divert the traffic to other group of healthy instances. What is 200 OK? 200 OK is the actually it's the default TCP message that's being sent. 200 OK is a message. It's a status code. Yeah, it's a standard response code. Like we say hello. What is hello? It's a standard response, or standard say hello, and you say hello back to me. It's a standard response. So in networking, 200 OK is an acknowledgement response, which means that the other side is functioning properly. It's a web interaction. Now, if this is unhealthy, it's down. The load balancer will divert the traffic to a group of other healthy instances, and until it comes back up, it will not receive any of the user's traffic. This is how it functions. Fine. The next thing that we're going to discuss is the cross-zone load balancing. What is this cross-zone load balancing? See, by default, the nature of the load balance is that it will divert equal amount of traffic based on the number of availability zones. So how many availability zones are there? 2. AP South 1A and AP South 1B. So load balancer will say, okay, I will send 50% of the traffic to availability zone A and 50% of the traffic to availability zone B. Life is good. Nothing is inhibited in this case. Now, this works in a scenario if you have equal amount of instances across different availability zones. Now, this thing you have to keep in mind. Amazon recommends that you deploy equal amount of instances across all the zones. For example, if 50% of traffic is going to the left side availability zone, so 25%, half will go over here, half will go over here, right? Same goes with the rest availability zone. 50% of traffic is distributed equally across these two different instances. Okay, this is how it functions. So AWS recommends that you should have equal number of instances being deployed, because the load balancer will divert the traffic based on the number of availability zones, and then gradually the instance will take over. But in some situation, you may say, okay, I don't go with the AWS best practice. Okay, I will have 10 instances running in availability zone A and only 2 instances running in availability zone B. You may have this requirement where you don't go with the Amazon's best practice and say, okay, I will deploy 10 instances in availability zone A and 2 instances in availability zone B. Now, so what issue will erupt in this case? The issue would be that half of the traffic is going to 10 instances and rest half is going to 2 instances. So these 2 instances will be overloaded. Can you see the discrepancy, the disbalance? So you're exhausting these 2 instances to a very high point that they can go down, or there's something wrong they will have, or they will not be able to process the information. Okay, so in that case, there's an option that you need to check, that is cross-zone load balancing. If you check this option, what happens? In the cases, if you have unequal number of instances being launched across different availability zones, it will scatter the traffic equally across all the instances. It will say, okay, I will not go with availability zone load balancing. I will load balance the traffic equally. So it will say, okay, I will distribute 100% of the traffic equally across all the 12 instances. So irrespective where they're being launched, I will ensure that 100% of the traffic is being deployed equally and uniformly across all. Now you can do the math, divide 100 by 12. So in the cases, unequal number of instances across different availability zones, instead of sending the traffic based on the number of availability zones, it will divert the traffic uniformly across all the instances. This concept is called cross-zone load balancing. Okay, if you go against the AWS recommendation, you don't have equal amount of instances across all the zones. In that case, the availability zone, which has less number of instances, will be overloaded or exhausted with a lot of information coming in. To ensure that there's no discrepancy.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 has how many pricing components? A. Only 4. B. Only 5. C. Only 3. D. Only 2. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Or you ensure that none of the instances is being overloaded. Then you check this option so that every instance gets the equal amount of traffic. Let's discuss the deployment process of the load balancer. You go with the load balancers, and what you're going to do is that let me do one thing. Let me deploy 2 instances first. Okay, let me do one thing. I need to ensure, we can just create, one thing we can do is that we can manufacture 2 different security groups first, one for the load balancer and another one for the instances. See, one thing you have to understand, the load balancer will get the traffic inbound from outside, and it will divert the traffic externally to the instances. So first thing first, I'll create 2 different security groups. In this case, I just name it as, for example, this is my application load balancer security group. Right now, I just type in, for example, this security group will be assigned to my application load balancer. Fine. Now, why we are designing these 2 different groups? What's the purpose behind that? The purpose behind having these 2 security groups means you ensure that we segregate the traffic. See, load balancer would be at the front end. Right now, I would say, because it will be at the front end, it will receive the HTTP traffic. Okay, let's do one thing. Let's not create the rules first. Let's define the group. We'll manipulate the rules afterward. Okay. So what is this? This is my application load balancer security group, and this would be assigned to my application load balancer. Click on create security group. Done. Right. So I'll create a second one. So let's do that. I think I've already done that. So let me just label it one more time. Done. Now I just create another security group. That is the EC2 instances security group. Okay. Now I just label them. We assigned to a group of EC2 instances. Done. So this will be assigned to the backend instances. Make sure that the VPC is same. I'll now define the rules as if now. I click on create security group. Okay, let me just add a tag so that I can label it afterwards. So I'll just name it as EC2 instances security group and click on create. Now, why did I create these 2 security groups? There's a reason behind that. Let me see if I can. Let me see if I can just. And let me filter the other one. That is the. So these are 2 different security groups that I've just manufactured in front of you. Now, what's the purpose behind these 2 different security groups? So you have to understand that how the traffic will flow. See, basically the purpose behind this entire thing is that I need to ensure we can easily segregate the traffic based on the user's request. Now, what happens is that this is my user. Fine. This user will divert the traffic to, so the user will send the traffic to the load balancer. Fine. Now the load balancer will what it will do is that it will forward the traffic to a group of instances at a backend. They may be scattered in single or multiple availability zones. So for example, these are a group of instances. These are my instances. Right now, what I'm trying to do is that I want to ensure that how it functions. So the traffic hits there. So what I'm saying is that I'll define a different security group for the load balancer. One is ALB-SG. One is ALB-SG. So this is the security group for the load balancer. Now, how I will define the inbound? So inbound, the traffic is coming from the, for example, internet user. So I'm saying inbound is, so for example, it's the HTTP traffic coming in. So I'm saying inbound, the HTTP traffic is coming from where? Anywhere. It's coming from anywhere. So in the load balancer security group, I will say that the traffic will be sent would be allowed inbound from anywhere, right? Because this is the any IP. This is anywhere. But what about outbound? The outbound traffic will be sent to a group of instances. Now, basically, how you can define the group of instances? That's the question. How you can define the group of instances? So I would say the outbound traffic would be sent to the security group that would be sent. So the outbound HTTP traffic would be sent to the instances at the backend, to the group of instances. So I'm saying that instead of sending the traffic to the two individual instances, I'll group them in security group, and this is how I will divert the traffic.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
You understand the point? The inbound is coming from anywhere. The outbound is being sent to a group of instances. So how will I do that? I go to the this thing, the application load balancer security group. I click on this. So I would say that edit inbound rules. So what I'm going to say is that I add a rule where I would say HTTP is coming from anywhere. I choose IPv4 anywhere. So I would say HTTP from the internet users. Done. That's it. I click on save. So it will process the inbound traffic coming from the internet. But what about outbound? I go to the outbound. I would say now outbound, whenever you create any new security group from scratch, the outbound is allowed to, so it allows all the traffic to all the destinations. Now this is what I want to remove, because I want to restrict the traffic flow. So I edit it right now. I would say that let's allow the HTTP traffic outbound to a custom source. And what was the custom source? That is the EC2 instances security group. Okay, you may not specify a reference group ID for an existing IPv4 CIDR rule. Let me just delete this one, create a new one from scratch. So I just say, let me, okay, now this will allow me. So I just type in EC2. This is the one, I think. Now, actually, let me just, what was happening is that it's not, I was just trying to customize the existing rule. It say that don't change the existing rule, create a new one. So it is same. It is same. If I choose EC2 instances -HE, this is the one I was selecting before. So I say outbound HTTP to anywhere. I'm sorry, to EC2 security group, to the group of instances. Fine. So whichever instance will get this security group will get the HTTP traffic from the load balancer. Save. You got the point? So it's saying inbound from the user, outbound to the group of instances that are collected in the form of the security group. You understand the logic behind that? That's what we're trying to achieve. That's what we are trying to achieve. Okay, now let's go to the next thing. What about the instance? See, instance will get the inbound traffic from the load balancer. So it will say HTTP inbound will come from the load balancer security group. And what about outbound? It will send the traffic outbound to the user. So it will say anywhere. So we'll say outbound to the internet, because it's sending back the traffic back to the internet. So it would be anywhere. It would be anywhere. So it will receive the traffic inbound from the load balancer's security group and divert the traffic outbound to any user on the internet. So basically, it will pick the user. So the thing is that any instance will pick the request and will send it back to the user. But because the traffic is going towards the internet, we'll choose anywhere. So that can freely go. It can freely go towards the internet. Fine. So how will I do that? I just should be the inbound. Okay. So inbound HTTP should come from the load balancer. So in that case, what I will do is that I'll just go to the security group of the instance. So I think, yeah, this is the security group of the instance. This is the Eastminster security group. I would say the inbound, just hit edit, I add a rule. So I would choose HTTP would be allowed from the application load balancer security group. So I would say inbound. Now this is for the backend instances. Inbound HTTP from the ALB. Done. Click on save. And what about outbound? towards the internet. So the outbound traffic just go to the outbound, and it will just have the default all traffic rule. I just go to edit. Let's remove that. I would say the outbound HTTP traffic will go from to anywhere. So HTTP outbound towards the internet. Click on save rules. Now this will ensure that I restrict the traffic internally and externally. This will ensure that we can restrict the traffic. Now, let's do one thing. Let's deploy 2 instances using the script that I've shared with you. Let's do that. Okay, so let me deploy 2 instances. I'm using the Amazon Linux 2 AMI. Click on select, and I just deploy instance in one of the availability zones, and let's make use of the script. This will install the Apache upon the instance itself. So let's copy and paste that. This is web server 01. Now this will install the Apache upon the instance, and this is the page that will show up. Okay, click on extract storage, extract tags. Let me add a tag. Okay, so I just label it as web server 01 so that I can easily recognize it, and I will apply this security group that I've already pre-configured. This one. Okay, review and launch. Continue, launch. Use one of the existing key pairs. So I need to make sure that the key pair is on my my desktop, and yeah, it's there. A launch instance. Now I quickly launch a duplicate instance in a different availability zone. Just to make sure that I just quickly go through it, I just changed the script text to web server 02 so that we can differentiate between these 2 different load balancers instances. So this is my web server 02. Okay, click on extract storage, extract tags. Just name it as web server 02 without any issues. So that we can just recognize that on the web page, and click on next configure security group. Now I'm just picking the same security group being that we have configured beforehand. Review and launch, continue, launch, choose the key pair and launch the instance. Done. So the instance is being launched. Now, these are 2 web servers I've launched. Let me label them for you. So filter them for you so that okay, a web server, okay, let me just put as web server 0. Okay, so these are the 2 web servers that we have deployed. Now, these 2 web servers that I've deployed will have the Apache running upon them. They will serve your web page, but we need to put them under the load balancer's authority. So how will I do that? Let's start with the process of deploying the application load balancer. I go to the load balancer, and let me just create a load balancer real quick. And what will I do next is that these are the 4 different load balancers that are presented in front of me. Now you can see that the classic one is almost on the verge of being retired. So AWS will retire the classic network, this classic load balancer on August 15, 2022. So don't use that. So you have 3 different load balancers in front of you. Gateway is the newest one. It is used for external virtual appliances. For example, you're using some VMware virtual machines in your own premises, or maybe you've migrated them on AWS, then you'll be using for that. But this is the newest of the entire lot. Still, I haven't seen being used at a very extensive scale. The most you'll be using, would be application or network. But application will be using in most of the scenarios. And this is what we're going to deploy. Now, I click on create load balancer for the application. Now, the very first thing that you need to, so you can see over here how this works. Your client makes a request to the application. The listener, so we configure the listeners for the application load balancer. It evaluates the request and forwards to the request based on the content of the request, right? So this is, you can see that how it works. Now, the very first thing is that I will just assign a name to it, demo, application. So you can assign any random name to it. Fine. Now you have to define a scheme for it. It's internet facing or it's internal. Now, most of the times you'll go with internet facing. Internal means that it will not get the internet traffic. It is only used for the internal routing purpose. You can use both that. You can use one for the internal, another one for the external. But for most of the web-based applications, you'll be using the internet-facing load balancer, which means that it gets the traffic from the internet. So in the example that we are discussing, we'll be going with the internet-facing load balancer. Now, IPv4 address. Now, basically, IP address type. If you go IPv4, it can just only. So the thing is that it will, if you have the IPv4 scheme used, IPv4 is of 32 bits. then use this one. If you use a dual stack, then if you're using IPv6 addresses in your network, then you can go with that. You can go with dual stack, or you can just go with IPv4, right? So I'll just go with IPv4 because I'm not using any of the IPv6 128-bit hexadecimal IP addresses in any of my networking components. Networking mapping, and now I need to choose all the availability zones to ensure that my traffic is being diverted across all this thing, right? The next thing I will do is that, so each of these availability zones is linked to each one of these subnets. Now I'll be selecting the security group that I've pre-configured, the security group. Thereafter, I need to configure the listener. Now, what happens is that listener will listen to the request and forward to the target groups. Now, a target group is nothing but it's a group of instances. Now, the target group you need to configure. That target group will consist of targets, and those targets are your instances. Okay, so a listener is a process that checks for the connection request using protocol and port you configure. Traffic received by the listener is then routed per your specification, and basically you define a kind of, it's a kind of algorithm. You're saying, okay, you listen to the HTTP request over port 80 and divert the traffic to a set of targets that's encapsulated in different target groups. Now we don't have the target groups being manufactured. I click on the target group right now, and it will open a different page where I just specify the target. Now the beauty about the application load balancer is that it can work on different types of targets. Instances. So in our case, the targets are what? Instances. IP addresses. So you can also go with the on-premises resources. Lambda functions. Right? Lambda function we'll discuss afterwards. So basically, you can choose any one of these different types of targets. I choose instances because we are using instances as an example. In our case, target group name, you have to assign a name to it. Application load balancer. Okay, let me make it as target group 1. Fine, target group 1. Now, the target group, which will consist of my instances at targets, will consist of the instances, and they will listen to the request over using HTTP protocol over port 80. Okay, this is the VPC where this instance will be deployed. This target group would be deployed. You don't have to change the protocol version. HTTP one would work for most of the requests. Health checks. Now, this is very important. The purpose of the health check is that it ensures that only the healthy instances can receive the traffic. Only the healthy instances can receive the traffic. Now, you need to define the ping path. Now, ping path is the root document or the default web page of the web application running upon the instance itself. Now, if you see the script that we have used, what's the default page we have defined? Index.html. The script that we ran upon the instance, based on that, the root document, the default document, the home page is index.html. Okay, so based on that, I will just type in index.html. Okay, so type in index.html. Fine. So this will ping the default page. See, the thing is that if you want to ping something, you type in ping google.com, ping intellipaat.com. You're giving a path to it. So I'm saying ping the default page of my website to be deployed upon the instance. Okay. So this is a target group, which will consist of my targets, which will be my instances. I click on next, and now it will say that, okay, add the targets to the target group. I'll choose web server 01, web server 02, and I will just choose include as pending below. And these two other web servers being, so what they're trying to do is that they're trying to add themselves to the target group, which that target group would fall under my application load balancer. Okay, so I click on create target group. So I have this target group 1, which consists of these two different targets, which are my instances. Now I go to the load balancer. I just choose the target group that I have just manufactured. So can you just process this entire step? I have the application load balancer, which will send the traffic to a target group, and the target group will consist of a group of instances. Fine. You can have multiple target groups running under the same load balancer. Fine. Now you can add a tag. It's optional. This is a summary of the entire configuration that you have performed. Now, this is the entire configuration that we have done. Click on create load balancer, and this will create the load balancer, and click on view. Now it can take up to 50 minutes for the load balancer to be active. You can see that state is provisioning. It is still in the process to, yeah, you can forward to multiple target groups. Yeah, you can even create another target group and put that under the load balancer. So can you see that over here? This is my load balancer, and I go to the target groups. This is so I can add multiple target groups under the single load balancer that I can do, right? So that's being done. Now, it will take some time for the load balancer to be active because the state is provisioning. It will be active within few seconds. Few minutes, and thereafter I can test the functionality of the load balancer and to ensure that I can see whether it's working or not. You can monitor the performance of the load balancer using some CloudWatch metrics. We don't have to deep dive into these concepts. Integrated services. You can integrate the load balancer with some other services as well. Monitoring listeners. You can see some of the details over there. And we didn't see the cross-zone load balancing because cross-zone load balancing is mainly the function of the classic load balancer. So there was, I think it was in the advanced options. I'm not sure about it. Let me see that. We didn't have the cross-zone load balancing over here. So it's under the classic one. So over here, I go to the target groups on the left-hand side, and I need to see whether the targets have, see, the thing is that you can see that this is the health check attribute. So every 30 seconds, the health will be performed towards my healthy instances. Now, these instances are at the initial state. So what they're trying to do is that the targets, which are my instances, they're trying to add themselves, or you can see that it's the target registration is in progress. So the targets of instances are trying to register themselves, to add themselves to the target group and ensure they're healthy. So it is still the health status is initial. So they take by default up to 5 minutes. I think I can change the attributes if I want to do that. Yeah, I can manipulate that, but I don't want to touch upon the things. So it will take some time. Okay. Now, one thing you can see that it says the status is unhealthy. Now, this means that the targets have failed the health check. Now we need to troubleshoot that what went wrong. Maybe the application that we deployed upon the instances were not deployed properly, or we didn't apply the proper security group, or in that case, the health check failed. I need to see why the health check failed. I think there's something wrong that we did. Just give me 1 second over here. I need to ensure that the instances are running properly. Hang on 1 second over here, because if the application is running properly upon the instance, this means that nothing is wrong with the instance itself. Give me 1 second over here. Now let me just go back to the security group of the instance and ensure that I'm able to browse the website running upon the instance. So I just for this testing purpose, I'll allow the HTTP from anywhere. It should basically have it allowed from the load balancer, just to make sure I can test the application running upon the instances. So let me just check the public IP address of the first web server, just to make sure that it's working fine. Okay, I think there's something wrong with the deployment of the. Let me check the second instance. I think there's something wrong over here because. Okay, so I think the web applications, they didn't run properly upon the web server because the script that I've used. Okay, let me just reboot the instances real quick, just to make sure that if there's something, hang on 1 second. Actions. Let me do one thing. Sometimes what happens is that based on the some issue at the back end, some regions, they don't respond to the they don't have the web services being up and running. Give me 1 second. Give me a minute. Let me deploy a duplicate instance in North California and see that if the services are working properly in that region or not. Give me a minute over here. Let me just deploy one single instance real quick, just to ensure that because sometimes sometimes it becomes a region-specific issue, and the applications, they don't respond properly on a specific region. Just give me 1 second over here. Because the configuration that we have performed, it's perfect. Nothing is wrong from our perspective. I just want to test that there's nothing wrong with the web services running in North Virginia. Sometimes there's some backend issue, the account specific issue. I need to open a ticket with support team so that they can initiate some services in North Virginia. Sometimes it happens, but I need to make sure that that's not the case. So I just deployed duplicate instance in California just to ensure that it responds properly. I'm just making sure that if that's the case, then we'll duplicate the infrastructure in California quickly. Okay, let me just wait for a few seconds and see that because sometimes it's an account specific issue. In these kind of scenarios, we can run some log traces to know the issue of the instance. See, we can I can enable a service called CloudTrail, which you command in that case. but I haven't enabled that service as of now. I can do the logs and troubleshooting, but it would be, so in that case, I need to I need to enable CloudTrail beforehand. And going with the logs and trail becomes much more complicated, because you have to see the entire logs and see that what's going on. Sometimes, very few scenarios is that sometimes the logs will not be able to show you the entire picture. So yeah, CloudTrail. It's a different service I will discuss with you afterwards, but I need to just make sure that these services are working properly. Let me see this, copy and paste the public IP address and see that if it's working. It's working in California, right? This means that there's something wrong for my account. The same web services are not running in Virginia. This happens sometimes. I need to open a ticket with them and ensure that the applications can run properly in Virginia. This is the issue. I duplicated the same application, same script in California. It's working perfectly fine. Okay, this happens sometimes. So I need to open a ticket with them. Once I'm through with this class, I'll open a ticket with them. Okay, so this means that there's something wrong with Virginia, and the web services are not responding. And this may happen to you as well. Sometimes you open an account, you deploy any web application, and nothing works. You have to open a ticket with them. They will enable some web services at their end. In my case, there's something wrong with the web services running in North Virginia, but in California, it's working fine. So I'll just duplicate the this deployment real quick in California. I've already explained you the stuff, right? So I not do that again. I just duplicate the entire infrastructure in California just in 2 minutes. Okay, just give me 2 minutes over here. I need to make sure that I just do that real quick. And see, these things come with experience. As you start working on AWS, you will see that these problems will come up, and based on experience, you'll be able to anticipate that what might be the issue. So it is all based on your experience and your amount of time you have spent working on this page. Okay, just give me one thing. Give me real quick 1 minute. I need to see that where this instance is deployed, in which availability zone. Just give me 1 second over here. Okay, it's running in US West 1C. Okay, let me deploy a duplicate instance in a different availability zone real quick. Just give me 1 second over here. So guys, this is a troubleshooting step for you. If it doesn't work in one region, use the other one and open a ticket with support team saying that it's not working in this availability zone, and they will reinstate your services. Yes, Sujit, it's available in free to your account as well. It's free of cost, but there's you have to pay for the amount of storage because the logs are being saved into an Amazon S3 bucket. So you have to pay for the storage. It's available in the free account, but you have to bear the storage cost for the logs. Okay. But that's okay. So I just really quickly, I just deploy the instance. And what I will do next is that I will just deploy a load balancer real quick, and making sure that create a target group. Let me just register these targets to target group. Okay, and let me just apply a security group. I've just duplicated the entire stuff. So the load balancer is being deployed, and it's in a state of provisioning. Now I'm eagerly waiting for the targets to be added on or to register themselves with the target group. So I'm just waiting for them to initialize, because you can see that the target registration process, registration is in progress. So I'm eagerly waiting for them to become healthy, to become available, add themselves to the target group, and then the target group, which consists of these two different targets or instances, can be added on the load balancer, and the load balancer can divert the traffic to the entire target group or these instances. So let's wait. Let's keep our finger crossed, and let's see that if it responds to our request. Let's wait for a few more seconds, and in the meantime, if it is check the DNS name of the load balancer, I think it will take some time. Let's see. Okay, it's working.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
Now that we are done with the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat.